Hi children, let's begin this session by studying chemistry, that too the first chapter of class 12 chemistry, the solid state. Everything around us, including we ourselves, are made up of matter. Among the three states of matter, solid, liquid and gas, in class 11, we studied very well the two states of matter, that is liquid and gas. In class 12, we will make a very in-depth study about the solid state, though we study only superficially in class 5 and 6 about the solid state. This chapter, solid state, has a weightage of 4 marks in AISSE examination, and the questions are of 1 mark, 2 mark and 3 marks. This chapter, solid state, comprises of 7 subtopics, which includes the first topic, general characteristics of solids. Second subtopic, classification of solids based on the arrangement of particles, and another classification which is based on the binding force between the particles with which a solid is made up of. Third subtopic, crystal lattice and unit cell. Fourth topic, close packed structures and packing efficiency. Fifth topic, calculation of density of various unit cells. Sixth topic, defects or imperfections generally seen in solids. And the last topic is electrical and magnetic properties of solids, which includes band theory. Let's move on to the first subtopic, which you are quite familiar of, you study in previous classes, that is general characteristics of solids. I'm 100% sure all of you are quite familiar with the general characteristics of solids, which includes solids have definite shape, because we know the particles with which the solid is made up of are closely packed. Second point, solids have definite volume. They won't fly away, the particles won't fly away when we keep it in some place. Now, move on to the third point. Solids are incompressible. Among the three states of matter, solids are the most compressed one. I mean, the particles in the solids are closely packed. Or it is said the compressibility of solid particles are about 10 raised to 6 times more than the particles of the gaseous state of matter, or the state of matter which is in the gaseous state. So the third general characteristics of solid is solids are incompressible. The fourth characteristic, solids have high density. We know density is equal to mass by volume. And since the particles in the solids are closely packed, its volume will be less for a unit mass. So its density will be higher, because mass by volume is density. Now the fifth point, solids have high intermolecular forces of attraction. Actually, this attractive force of particles between the solids tends to keep the particles closer. So the general characteristics of solids, which we have studied in the previous classes, is over. Solids have definite shape, solids have definite volume, solids are incompressible, solids have high density, and intermolecular force of attraction between the solids are stronger. Now move on to the next topic, classification of solids based on the arrangement of particles. Based on the arrangement of particles, solids are classified into crystalline and amorphous solids. So let me repeat once again. Based on the arrangement of particles seen in a solid, solids are classified into crystalline and amorphous solids. Now we will see each point how a crystalline and amorphous solids differ each other. The first point, crystalline solids have sharp melting point and boiling point, and amorphous solids they don't have sharp melting point and boiling point. So that is the first and the foremost difference. Crystalline solids, if a solid is crystalline, it will melt at a sharp particular temperature, and boiling point also the same. Now move on to the next difference. Crystalline solids are anisotropic, but amorphous solids are isotropic. This anisotropy is very important from the examination point of view. Usually that question comes for the exam. Anisotropy means it is a phenomenon in which a solid will have different physical properties along different directions. I will illustrate this. See, this is a crystalline solid. And we know crystalline solids. In crystalline solids, the particles are arranged in a definite ordered pattern. Let's take an example of crystalline solid, that is sodium chloride or NaCl. And here it is shown sodium ions. Sodium ions, let it be in round circles, and chloride ions in green circle. See how they are arranged. But then why a difference in property comes in the same solid? This is due to, if we go down, vertically go down, a line is drawn. See, on both sides of the line, on one side only sodium ions are seen, and on the other side chloride ions are seen. But if we go diagonally, on both the sides of this line, both the ions are seen. So, due to this difference in the arrangement of particles, crystalline solids show different physical properties like electrical resistance, electrical and thermal conductivity, then a major difference in refractive index. But in amorphous solids, because the particles are randomly arranged, so though we draw a line along any direction, the arrangement of particles on both the lines will be one and the same. So they don't show difference in the physical properties like electrical resistance, electrical and thermal conductivity, and refractive index. Now, third difference, crystalline solids, when we cut it, we get well-defined cleavage plane. You might have seen when we cut some metals. Now we can see the plane, that cleavage plane is very smooth. So it's a property of a crystalline solid. Crystalline solids, when we cut it, it gives a well-defined cleavage plane. Instead of amorphous solids, it will not give a well-defined cleavage plane. The fourth difference, crystalline solids have long-range order. I told you, when we draw a line along any direction, the arrangement of particles on both sides of that line will be one and the same for the entire crystal. But for amorphous solids, the uniformity is seen only in a short range, or we can say amorphous solids have short range order. The next difference is crystalline solids have definite geometrical pattern, and amorphous solids do not have a definite geometrical pattern. For example, a crystalline solid I am showing previously also to represent anisotropy and isotropy. I showed you the same pattern, and now this is a crystalline solid because the particles are arranged in a very ordered fashion. I will show you a particular geometrical pattern which is getting created. See, now we can create a geometrical pattern for crystalline solids, and for amorphous solids, since the particles are arranged in a very random fashion, we cannot create such geometrical forms. Now, the last difference. Crystalline solids are true solids, but amorphous solids are pseudo-solids. Pseudo-solids mean these amorphous solids at times show the properties of liquids. That means they flow like fluids. You might have seen in very old buildings that the glass window panes are thicker at the bottom and thinner at the top. This is because the particles have, by the time they flew downwards. And these are the differences between crystalline and amorphous solids. Now, our study is getting streamlined to crystalline solids only in this chapter, the solid state. Now, the next topic, the same subtopic, classification of solids. We are classifying the crystalline solids into, this is an example for a crystalline solid I am showing you, and an example for a amorphous solid. Here we cannot draw a specific pattern. Here 1, 2, 3, 4, 5, 6, 7, 8 lines can be seen in a single unit, and here only 4 lines. So in amorphous solids, it is not arranged in an ordered fashion, and in crystalline solids, everything is in ordered fashion. Now, the next topic is classification of solids based on the binding force. Classification of solids based on arrangement of particles is over. Now we are moving on to the next topic, classification of solids based on the binding force between the particles. And that too, even we are talking about crystalline solids. Crystalline solids are classified into 4 major solids. They are molecular solid, second one ionic solid, third one covalent solid, and fourth one it is metallic solid. Now move on to the first category of crystalline solid, that is molecular solids. Sorry, this is 3 types, not 2 types. Molecular solids are classified into 3 types of solids. The first one is polar molecular solid. Polar molecular solid means each particle is a molecule, but it is existing as dipole. It is existing as dipole. It doesn't mean it is a good conductor of electricity, because its dipole or polar nature is getting neutralized in the molecule itself. So polar molecular solid means it is made up of dipoles, and the characteristics of polar molecular solids are: number 1, it is soft to an extent. To an extent it is soft, not very hard. Second one, since they are soft, they have low melting point and boiling point. But one thing I want to, the comparison I will do afterwards. They have low melting point and boiling point. The third property is that the intermolecular force of attraction between the particle is dipole-dipole interaction. In class 11, about when I taught the lesson states of matter, I told you different types of van der Waals force. Among the first one is London force. Second one is dipole-dipole interaction. Third one is dipole-induced dipole, and the fourth one is hydrogen bonding. Among that, dipole-dipole interaction is seen between polar molecular solids, and its characteristics are: they are soft, they have low melting point, boiling point, and intermolecular force of attraction seen is dipole-dipole interaction. The second type of molecular solid is nonpolar molecular solid. Nonpolar molecular solid examples are solid hydrogen, solid chlorine, solid iodine, solid argon, etc. Here we are talking about the interaction existing between one molecule and the other molecule. Here the interaction is very weak. For example, one hydrogen molecule and another hydrogen molecule, the interaction is only weak London force, or another name for London force is weak dispersion force. And the properties are, again, they are soft, and their melting point and boiling point is very low and it will be lower than polar molecular solid. And the force of attraction or intermolecular force of attraction is dispersion force. Now moving on to the third category of the molecular solid, it is hydrogen bonded molecular solid. Examples are solid hydrogen fluoride or solid water, which is ice. Here we can say they are also soft. They are also soft and their melting point and boiling point. Their melting point and boiling point is low, but now we are able to compare the strength, compare the value of the boiling point and melting point. Among the molecular solids, hydrogen bonded molecular solid has the highest melting point and boiling point. Then comes polar molecular solid, and after that the solid with least melting point and boiling point is non-polar molecular solid. I think now you are able to say the characteristics of hydrogen bonded molecular solid. The first one it is they are soft. Second one, they have low melting and boiling point but comparatively higher than polar molecular solid and non-polar molecular solid. And the third one, intermolecular force of attraction between the particles is hydrogen bonding. It is shown by dotted lines here, hydrogen bonding. So that is about the molecular solid. The second type of crystalline solid is ionic solids. It is represented here. Examples for ionic solids are NaCl, common salt, KCl, CuSO4, that copper sulfate, all are examples for ionic solids. Here, the constituent ions are kept in an ordered fashion, and there is strong that electrostatic force of attraction between them. So now we are able to explain the characteristics. Number one, they are hard. Number two, they have high melting point and boiling point. What about its conductivity? We can say that they are good conductors because since they are existing in the form of ions, they are good conductors of electricity in one condition, in molten state or in aqueous state. In solid state, they are poor conductors of electricity, or we can say they are non-conductors of electricity. But in molten state or in aqueous state, these ionic solids are good conductors of electricity. And another point we have to say is about the intermolecular or interionic force of attraction. It is electrostatic force of attraction. These are the characteristics of ionic solids. Don't worry, children, I will give everything in the note. The third type of crystalline solid is covalent solids. Among the different types of crystalline solids, covalent solids are the hard, at the same time have high melting point and boiling point. Besides, in these type of solids, the bond between the molecules are covalent bond. Familiar example of covalent solids are diamond. We know how much strong it is. Another example is carborundum, which is silicon carbide. Both these substances are used as abrasives in markets. So, let me tell you once again the characteristics of covalent solids. First one, they are very hard because strong covalent bonding is seen between the particles. Second one, because of this strong covalent bond, they have high melting point and boiling point. And the third characteristic is intermolecular force of attraction between the particles are covalent bonding. Now we are moving on to this is diamond, this is graphite. Both are covalent solids. Now we move on to the last type of crystalline solid, that is metallic solids. Metals. We know how the particles are arranged in a metal, and we will study very well about the bonding seen in metallic solids at the latter half of this chapter. And let me tell you, in metals, the metallic bonding theory says Metals are made up of metal atoms, or otherwise we can say they are positively charged cations. And each metal atom releases electrons and it will be seen in its premises. I am showing here the cation, at the same time the electrons present near to it. And these free electrons, these horizontal lines are electrons, and these free electrons gives the lustrous nature for the metals, at the same time makes metals a very good conductor of electricity. So about metallic solids, the general characteristics are: metals are hard as well as soft. A few metals are hard and another category of metals are soft. The second characteristic is they have moderately high melting point and boiling point because of this metallic bonding. Metallic bonding is between here in this diagram, the electrons are shown as red small circles and the cations are arranged in a regular pattern. And this, or we can say in metals, it is said these cations are seen in a sea of electrons. So consider a pool where electrons are kept and cations are plunged into that pool. So this metallic bonding theory says about its structure. So the fourth type of the metallic solid, let me say once again the characteristic they are hard as well as soft. They have moderately high melting point and boiling point. At the same time, the intermolecular force of attraction seen in metallic solids are metallic bonding. So now the classification of solids based on the binding force between the particles is